start again. Dr. Shitala Prasad is currently working as scientist at Institute of Infocomm Research, A Star, Singapore. He was previously a research fellow at CYSREN at the rate at NTU Singapore, where he was working on text spotting and deep learning in natural scene understanding and forensic. Prior to that, he was a postdoctoral fellow at GREYC Lab Center at Uniquen, France, where he worked on image uh, aestheticness computation. He received his PhD from Indian Institute of Technology, Roorkee in Computer Science and Engineering Department in February 2016 and MTech degree from Indian Institute of Information Technology, Allahabad in Information Technology in the year 2011. He is Bachelor of Technology in Computer Science from IILM India in 2009 and is specialized in Human Computer Interface HCI. His major research work interest is in computer vision, gesture recognition, virtual and augmented reality, OH character recognition. He also works on mobile agro imaging for cloud computing in Android environment, agriculture as a service. With this, I now welcome today's speaker, Dr. Shitala Prasad. Over to you, sir.
Hi, thank you very much. Thank you very much for your attention.
Hello.
Is it
Sir,
audible?
it is not
Is it audible to you?
Shitala sir, actually
Is
your
it-
voice
is
is
it audible
low.
now?
Yeah,
It's
your
not
voice is very low.
everybody the same thing
Then let me.
for everybody.
Okay. Let me try it.
Hello.
How about now? Is it audible?
Yes, sir, now it is audible, sir.
Yeah. Okay. Then I'll try to follow this one. This settings. Okay. So can I share my screen?
Sure, sir.
Okay. Please let me know if you can see my screen. Is my screen visible to you guys?
No, sir, your screen is not visible. It is completely black, sir.
No. Okay. Let me try again. Is it visible now?
Still not, sir.
True. Hold on. Not yet.
Yeah, not yet, sir.
Let me share the complete window. Is it now visible or not yet?
Sir, not yet, sir.
Why it is not visible? I just need to select the window option and the slide right. I'm selecting the same thing. I can see that my screen shows presenting the slide.
Okay. Participants, is the screen visible to you?
No, sir.
Sir, it is not.
No, sir.
Okay.
No, sir.
Let me reconnect then in that case. Give me a minute.
Okay, sure, sir.
Can you see now?
Not yet, sir.
Am I allowed to share my screen or not? I mean,
Yeah, you are.
because in my screen, on my
Yes, sir.
screen,
You
I
are
can.
allowed. You are allowed to share your screen.
It is not showing. I I really don't know what's wrong with it.
Sir, can you please
Because on my
check?
screen it shows.
Yes, sir. Now it is visible, sir.
Is visible now?
Yes, it is visible
I
now.
think it's some delay.
Yes, sir, it is visible, sir.
Okay, fine, thanks. Uh, I think it's a little bit delayed or what.
Maybe, sir.
Okay. So hi everyone. This is Shitala. I work as a scientist in ACE. So today's my talk will be related to data-centric AI in object detections using deep features. So mostly it will cover about the detections and the feature representations and other things. Most of the time, I think most of the things you might have come across, but we'll just give a very uh, brief intro to those things and how we tackle with the problems with the new data or with the wrong labelings or something like that. So before that, I'd like to just highlight few things about myself, which already the host have announced. I work as a scientist. Before that, I was with NTU and CNRS France. Did my PhD from IIT and masters from IIIT Allahabad and BTech from CET College. So I'm also a young researcher awardee. And yeah, my research interests mostly includes image processing, vision processing, object detections, classification, segmentations, pattern recognitions, and of course, biometrics and biomedical, including your BCI and HCI. I'm also interested in edge and cloud computing. So, but today's talk will be mostly related to computer visions, challenges, data sets, and their types of model training. And then we'll cover about the model-based centric AI and database centric AI. In database centric AI, I'll just cover about the object detections. In that, I'll cover text spotting in real scenario, wildlife scenario. So as you all guys know about this computer vision, it's like have a vast applications in many of the fields, including your neuroscience, optics, and and other robotics, machine learning things. So physics, bio, every field they use computer vision for some or the other tasks. So that's why nowadays there are many algorithms coming up with uh, new solutions, coming up with solutions for vision-based tasks, whether it is micro level or normal vision based. So the most important task in computer vision is like object detections, classifications, and segmentations. That is what we broadly classify. But then after that, there are many other things which actually use these informations for further controlling the devices or further taking a decision for any other uh, action to be taken, like in a camera or in a vehicle, automobiles. So just to give a clear picture, if you guys haven't come across these things, so it's like something in computer vision. Most of the times now we are using CNN, but before that try to use traditional methods. We try to compute the features and then use machine learning algorithms for classifications of recognitions. But now everything is impossible with just using one CNN network. So your segmentation, that is your semantic segmentations or instance segmentations, can be possible with CNN. So these four tasks are very important in computer vision, which is very much feasible, or deep learning can solve these problems very much comfortably and equivalent to a real vision. somewhat, sometimes even better than human vision. So the challenge in this is like when we have multi-oriented uh, view, say for example, your camera is from viewing from one angle. What if your camera does suddenly changes the view for the same object, which the network has learned already? In that case, the same network will fail. So is it possible to come up with some or the other way where your common features can be recorded, and whenever the view is changed, your recognition is still having a high performance? Then your illumination, this actually multi-view is a big challenge when you have mechanical parts in real world, or you have some uh, medical things, biomedical things, because you view some from some angle the object is circular, but from some angle the object might be square. So these challenges are very much important, we need to tackle out. So there are researchers working on these multi-view object recognitions, then illuminations, then deformations, then occlusions. Other than this, the challenge also occurs with the image types like cluttered background or like intra-class variants. When you have your background is exactly matching compared to your foreground, in that case the problem do occur and our current model do fail. So how to tackle with those things? And also intra-class variants, so all are cats but of different variants. So how to do? So for that, the most important things we need to look after is if we have a data set and we have those data sets properly labeled, then your existing models might work very good. But what if like you don't have the data set, or if you have a data set, the annotation has some problems or some other issues comes with the data sets. In that case, the present model might fail or will give you a bad performance. So ImageNet is uh, one of the biggest data set for image classification, but now has been replaced by Open Image. So these are the data sets which are usually being used for object classifications, and now they are being taken off with some other data sets which is much better than them. This is just an overview where your vision data sets for ImageNet and their models are actually working. So now at right now we are capable of having 90.45% of accuracy for ImageNet data sets. So that means you can still see 10% still there is like of error. So people are trying to do more and more research in the in network architecture. So they are coming up with better and better architecture that gives us a better and best feature representations to have an object classification or to have a image classifications. But still the problem is like all models are dependent on the data sets, and if the data sets is changed, the same model will not perform exactly the same way of what they were performing on the train image. So this is another data set which is coco, and for coco we still are somewhat like here 61.3%. So it's a little bit more challenging compared to ImageNet as from the statistic. And the soft teacher approach is actually working best because they involve multiple level of training, not only just one go, but they are training in multiple layers, training something and then training on over it and then training over it. So that's why this performs much better compared to the other state of the methods. So I'll just skip this one. So deep learning usually they involve two things, either loss. I mean, you need to consider like how you're going to train them in network, and then what kind of loss you're going to use during the training. So if you can formulate these two things, you can definitely come up with a better performance. But the other problem is network architecture. The complex network architecture you have, the better performance or the better representations you might get, but the problem is like the more complicated you have, the more problem will occur when you are training it, because the training conversation will be like very slow. So you need to keep training it for like more than days. So that will actually create a problem. So we need to consider all those things before we start our training, before we start our network designing, and also defining our loss functions. So I'll just come up with a deep learning approaches in two scenarios using your model centric and data centric. So if we talk about model centric, it's like something like you code and then you have a data set to be trained. So mostly the thing what we do is we do on the coding part, like we try to come up with better and better architectures. We come up with better and best training strategies to deal with the noise, or to generalize the noise and of the data set, and then come up with a best performance. So that's what we talk about. That's what is your model centric approach. But if we talk about data centric approach, as Andrew mentioned, uh, that in data centric approach we usually have the same model, or we have a existing network, and then we try to focus on the data part, like is our network learning something wrong, is the data set is properly defined, or the labeling is correct. Because usually when we come up with when we talk about data set, and it involves data annotations. Data annotations is basically a crowdsource based annotations, or at least it involves more than one person's labeling. So it might be possible that the labelings of a two-person for the same object might be a different way. So there might be some kind of issues. So how to deal with those kind of data? If we can rectify those kind of annotations, then maybe your same algorithm works much better for that data. So it's like it's like something you are mostly working on data part compared to the algorithmic part. So my talk will be mostly in this direction. So for example, there can be one very simple example. There can be one very simple example is like improving the code versus training the data. So for example, if you are using a traditional method, you have a data set, you have an algorithm, and you just directly train it. So he says like if the data set is your steel defect detection, the performance is limited to 76.2%. But if you try to use your data centric approach and try to rectify those datas which is irrelevant, or is like wrongly labeled, or something like misleading the things, then your performance is directly boosted by 70%. So something like this. Here you can see your red one is labeled by one person and the blue one is labeled by the second person. So if your network sees these two images two times, it will be actually be confused, like either we need to have this one as a one single class, or the red one as a one single class. So there will be like too much of biased things for a network to learn. So generalization will have always a problem in that case. So network will always be limited to upper performance level, cannot learn more than that, because your data set is right now wrong. So in this data centric approach, we try to do this one. We try to rectify this thing and then come up with this kind of data annotations. And in this case, when you train your network will of course performs much better than the previous one, the same network, without modifying anything. So as a tip, like data centric AI, make sure that the labels is consistent. You can use multiple labelers, but multiple labelers might not have a consistency. So inconsistencies can be there. So you have to deal with those things first, and then clarify the labels instructions by tracking down the ambiguity. If you are talking about label aeroplane, then you should specify that when there is partially visible aeroplane, then how to annotate those things. And also toss out the noisy data so that it doesn't make uh, learning a problem. The more the data, of course, is good, but in this data centric approach, the correct data is the best thing, not just add on data, wrong data, and make the network confused or biased towards something. And then the last thing is use error annotation analysis to focus on the subsets of data for improvement. Whenever we try to learn something, we need to make sure that whenever there is some kind of error, how to rectify those errors to make sure that performance keeps growing, and learning does not stop at a threshold. Here is another example I mentioned. I tried to give a clear picture of each and every tips. This one is data consistency, or sorry, label consistency. So for example, if we have three labelers like label 1, label 2, label 3, then you can see like a labeler has labeled a data set using his own skill and labeled each and every word as one single bonding box with a one single bonding box. And in the second labeler, in the second label image, the second labeler has labeled each and every word as a single bonding box, but has missed these words. So at the time of learning, the network will try to learn these words as a correct one, but these words as a foreground information, as a negative information. So network will get confused. Whereas in this case, whereas in the third label case, you can see that our labeler has labeled complete chunk of or instance of many instances into single text instances, and that's why your private car parking is in a single bonding boxes. So network will again get confused when they see these three different types of labeling. So the generalization will have limitations. So if we can avoid this kind of annotations, maybe our performance get better. That's what the first step says. In your second step, your multi-labelers, to spot the inconsistency, you need to always look about the labels, bonding box size, and the number of image and the number of bonding boxes. Say, for example, in your first image, you have three bonding boxes for text instances, but here there you can see like there is one baby tea coffee, might be of three text instances or might be of two text instances at least. So there is like always a mismatch of the mismatch of count of number of boxes. Another thing is like you can have always a mismatch of size of bonding boxes. Someone creates a bigger bonding boxes, someone creates a smaller bonding boxes. Third thing can be your number of boxes, that is your yellow box. You can completely annotate them in a single bonding box, or you can annotate them in a different bonding boxes. So compared to the first one, it's like only three bonding box, but in your second image, sorry, last image, you have seven bonding boxes. So this is what actually multi-labelers actually adds on the problem or challenges to the deep networks. Third thing is your clarify the labels instructions. Like you need to clearly mention what is the annotations and how they need to be annotated and what should not be annotated. If you can do that, then your performance will definitely go up. The fourth thing is toss out the noisy things. So better toss out the noisy things so that network is not learning anything wrong. I have zoomed out some of the parts of this image, which the labeler has missed. Say, for example, this one, the labeler has missed to label them, but these can be like always removed because they are like blur and cannot be visible, for example. But in the second label, in the second case, in the second labeler's case, they have actually missed big things, which is clearly visible and which is clearly anyone can say is a text instances. So the labeling is important for that case. So this will actually create a problem. And of course, this one is wrong labeling. So we have to definitely remove these things. Otherwise, we cannot create a clear boundary. Always there will be a issue. So you can, if you want to graph learning strategy, training strategies, then we can see in this way. Small data with a noisy label uh, cannot create a bounding box, or cannot have a single bounding box to separate them out. And similarly, if you have a very big data set but noisy, then how to go? Cannot generalize it. So that's why if you even if you have a small data set but they are very clean, then the generalization or the training will be very smooth. Okay. Third thing is like data centric AI tips. Third thing is your NN analysis. So whenever you train your network, you definitely train your network using some or the other strategies while training on some fixed data sets. But what if like the data sets has different patterns? Like for example, here you have printed texts as well as you have handwritten texts as well as you have calligraphy things. So network is actually getting confused when they see these numbers in less quantity compared to the other text instances in more quantity. So if you can remove these things, the network will performance will definitely go up. Or you have to design your network to learn these things specifically. So this is an example of clean versus noisy data, where you can see accuracy between clean and noisy. The red one is noisy and the green one is clean. Same model, same data set, you can see the performance difference is quite high. And same number, even when we train for the same number of training a box. So that's why data centric is now we consider more important, rather than just creating bigger and bigger networks. We should also consider to clarify clean our network data. So here there is another process where data centric, I mean the life cycle of data centric, how it works. You need to have a training model, then see the error analysis, and then improve the data, and then again you train, and then it keeps on going. So the networks will keep on improving the performance step by step. Here are a few of the papers which actually are very close to data centric approaches. Maybe you can have it. You can go through these papers in later. Okay. So now coming back to the our objective, object detections. Object detections, as everybody knows, that it's a little bit different compared to the classification. Classification, you just need to classify there is a cat in a picture or not. But in object detections, you need to classify if there is a cat, then at what location. So you need to come up with the bounding boxes also. So if you have a big number of computing power, then it's very easy. You can have multiple number of bounding boxes in a very quick way. But what if like you have resource limitations and you need to get the response very quickly and correctly? Then how to deal with those things? So you need to come up with a very good solution in terms of network architecture, of course, and in terms of data definitions too. So these are few commonly used model-centric approach, where they are focusing on the model structures so that the performance on the data set is improved or is being rectified or enhanced. So most of the concentration is in these architectures. Most of the concentration is to design the better representations of a given input. But that's not the only thing we need to think about. Here there is the latest one which we use right now as efficient detection, where the backbone is your efficient net, and then they use it for uh, prediction of bounding boxes and the class. Okay, these are some of the data. I'll just skip them. Now the data, yeah. So now we should talk about is the data label consistency or making data quality systematic. We need to consider these things while object detection, because annotation is a big problem. So scope, collect your data, then train, and then deploy the productions. So here there is a few of our papers which actually uh, closely having a relationship with data centric. That is, either we can come up with a very good training strategy, or we can generate the pseudo datas. These pseudo data is generated from our initially or pre trained models. That pre-trained model is based specifically or dedicatedly trained on the given task, not on a generalized image such as ImageNet, and then use that trained model to generate more or annotate more data, and then use those pseudo table data for further training. So that way also it works. So here we actually try to focus on text detection rather than other detections. So I'll just limit my talk to text spotting. So the topic was something like object information for text spotting in natural image, where you are actually trying to add somehow empirically you are adding object information to make sure that the network knows that okay, this area or this region of an image is likely having to have a text instances rather than compared to the other areas. Say for example, if I show you these two images, you can see that there is some image which is mostly related to letter M or letter I. But if you completely see a complete picture of this, you can know that okay, this is not exact letter. This is actually misleading the network. Network is 92% confident that this scarf is letter M, but it's not true, because at the time of training they are learning from they are learning from a wild images. So these images might have a pattern which is quite similar to our text instances pattern. Say for example, your letter M is related to your scarf foldings. There might be some Chinese character. There might be some other character which is similar to the leaf folds or patterns. So in that case, network is not learning anything wrong, because networks only knows the pattern. So we need to feed the right pattern, and we need to make sure that network knows that okay, if there is some kind of pattern found in the plant or tree or sky or ground or something where it should not be, then the networks can be improved, that the network's performance can be improved. So we our focus in this paper is something related to something if we can make sure that the network knows that this region is positive or this region is negative, then our performance will be improved. The detection